is our muscle fiber.
It's amazing you can actually draw with a broken leg.
Why does the taller guy have a taller chair? You're shorter. You should be in the
So this
taller
is
one.
the this is the neuromuscular junction, and we have
No,
receptor
so-
sites here,
And that's the
and
motor
this is the
endpoint.
axon,
Ask her, so she got to answer.
the neuroaxon, and it sends electrical signal here that's picked up on here.
Those are receptors, right?
Those are receptors on the motor end.
Yeah,
To pick up
Yeah, the receptor.
to pick up the electrical impulse from the neuroaxon.
acetylchlorine.
Yeah,
ACH is calling, yeah.
right. And so then the ACH comes over here. No.
It's actually important. So what you said the electrical impulse comes from the neuron. No, neuron releases the chemical, which is ACH. ACH binds to the receptors, and
Okay.
then allows the ions to come in.
Okay.
The entry of the ions causes the electrical impulse to
Okay.
go along the membrane.
And that's in the sarcolemma.
That's on the
the
sarcolemma.
sarcolemma.
Yeah.
That's up here, right?
Yes. Correct.
It comes down
Goes to
there's-
where?
into the
Terminal cisterna.
Terminal cisterna.
What was it?
Terminal.
Terminal cisterna.
cisterna. And in here we have calcium ions, where they're stored, and when these
CA.
enter,
CA.
they're then can be released into the cell.
They bind to troponin.
They bind to tropin.
Well, no, they have to be
They
released
have to
first.
be released
Yeah, they have
first.
to be released first. You have another color here, in case you want to add. There's a red over there too.
Okay. So these are going to be blue, little calcium stuff. So we have myosin here, these heads, and actin. And these actin are covered by a...
If you have any question, just ask her. Slow her down and ask.
They're covered here, and they have a receptor site on the top where these calciums bind to, which then releases the head, so the heads are open, and these are like kind of magnets, is how I think of it, that then can bind to the actin. The myosin can bind to the actin. I'm forgetting the troponin.
Troponin opens
Tropomyosin is
the-
the one that's
This
like
thing.
Yeah, so the red one is the tropomyosin.
That's
Troponin
troponin
covered
changes
by
to the
it?
shape of
Yeah,
the
that's what
troponin.
Yeah,
opens
so
it, right?
tropomyosin.
And troponin
And
opens it.
troponin are
How you say
these
it?
Troponin.
troponin
Troponin
are
or
these
troponin?
sites that the
Oh,
calcium
okay.
can bind to.
Correct. So troponin basically provides a handle, basically.
Yes.
Troponin.
So troponin
Handle to open the binding cells.
equals handle, tropomyosin, which is red. Might spell the
No, we have a better red one right in front of you. That guy's.
Tropomyosin is the cover. So then the actin can bind with the myosin. And the actin is the thin filaments and the myosin are the thick filaments.
So in this context, what she talked about, basically, you're now naming all the components, and that's good enough. Is there detail? Yeah, there's detailed information, but
What
that's
would
going to
you
be
call
for
this
physiology.
process?
This is called the sliding filament mechanism.
Yeah. 'Cause
Sliding.
these guys slide across.
Yeah, because they're sliding, the actin is sliding over one another. That's what's called sliding filament.
So if you
Yes.
think of it as like the the thin filaments up here, the actin, and the thick filaments, the myosin, this slides across so they can bind to the site. They're able to bind together. They don't actually change in size, they just slide together.
And it
Just go to a
just,
point where they can
and
get
it
together,
just
set it.
results in a contraction. This is
Right.
how a contraction happens.
Yeah, basically those
It
two
moves it,
proteins, the
right?
actin molecules, they come forward like this, and that generates.
Good job.
Good job.
Good job.
I had a
Good
question
job.
though.
Yes.
And this is the sarcolemma. Or no.
No,
this is
T2
Yeah, the tubular.
T-tubule.
What does it have to do like with the whole mechanism?
transfers to
Let's see, somebody
So-
can answer that question. What does
Because I know it's
T2
part of the what's that membrane called? The P per.
What?
What's the membrane? Sarcolemma is part of that, right?
Is part of
Yeah.
that, but
What
it's
is-
special name.
The
It's called
deep part of that
Yeah.
sarcolemma
What-
that
he says
transfers.
that what does that have to do with this whole
T2
process?
Doesn't it, bring certain ions to the cells?
Very good. So she talked about electrical impulse or action potential traveling this way, right? If this wasn't for this, it'll go that way. Does it reach the same terminal cisternae? No. But because it's in here, that actually conducts the electrical activity into the terminal
So
cisternae.
it pushes it back then, right?
Well, it doesn't push it back, but basically this electrical impulse, like I said, imagine if this wasn't there and you
More
had
people.
membrane like this. So the electrical impulse would go there, this wouldn't be affected. The idea is that the electrical impulse affects, the tubules conducts electrical impulse deep into the muscle.
Oh, that's
Without it, you couldn't. None of the stuff would work without it.
So when it gets that electrical, like,
Impulse.
creates an electrical gradient, right?
Uh-huh.
That's this ACH, right? That's not the one coming down on the neuron?
ACH is not coming down.
Yeah.
But ACH, this is like I said, be careful, I don't want to go too much into depth, but basically the movement of ions creating a action potential or electrical impulse. What ions? Sodium, potassium. What they do, we don't care. You can learn about it later next
So
week.
we need potassium pump.
Yeah.
We learned about that last